At this stage, as soon as the cartridge is inserted in the instrument, the instrument prompts to calibrate the cartridge. But if it does not, and the cartridge has already been calibrated, this is where you go under the tools, recalibrate. So recalibration of the cartridge, basically it picks up the solution from the alignment marker, which is the 20 and the 1000 base pair lower and upper markers. It will calibrate, and the software show the two peaks individually run. After that, we proceed to the run of the DNA ladder. To run the DNA ladder, we basically, as we have loaded the samples in the positions, in this case, as you can see on the user interface, the sequence basically is to generate number of methods to run your samples. So it's very simple. You click the button add, and it will add a line in the sequence table. The first thing you would do is basically designate the sample. Of course, in our case, is in A1, position A1. But if you have some other samples, let's say you want to run a row of PCR products, if you have a 12-well strip, you will select the 12-well strip by hitting the A. Or if you want to go A to H, putting 8 sample runs, it will select A to H. Again, in this case, we are using A, so we will select A. And if you want to use a 96-well sample tray, you would of course select all the positions as designated. So again, we select A1, and we say OK. And also you have a table here which you basically enter the name of each sample position, or you can basically export or import from your Excel spreadsheet into this table all the 96-well sample names, and the software will recognize it. Once you have selected sample position, then you need to select a method, which method you're going to run. Basically, the software already recognizes through the when you lash the cartridge, there is an RFID buildup in the cartridge, and it will display what type of a cartridge it is. By recognizing the information stored in the RFID chip, it will say it's an S1 cartridge, has an expiration date which is typically 6 months expiration, stored at room temperature, and also the number of runs left, and also the description of the cartridge, which is, in this case, it's a high resolution cartridge. So again, to select a method, the methods are basically picked up by the RFID chip for this particular cartridge, which is an S1 cartridge, and it will say what kind of resolution, what kind of speed, what kind of voltages you want to run. Typically, you choose the first one. First one is a M4 method, and it will run a separation at 6 kV for 300 seconds. And sample injection would be 4 kV at 10 seconds. And this will, for an S1 cartridge, it will resolve 2 to 4 base pair resolution. So you will select this, say OK, and also you would put some sort of a name for your run. So for this one, I will say ladder 1, and we're ready to go. And then we will hit the run. And as you hear, the instrument is going through some positioning right now. It's basically every 5 minutes, the instrument automatically aligns the tray and put it in the park position to be able to secure the cartridge tip or protect the cartridge tip from drying out. if you forget to put it in the park position. So okay, now we are ready, so I'm gonna hit the run, and as you can see in the user interface, it positions A1. This is the part that we selected, and it's pointing it red color. Of course, once the run is completed, it will turn to green, and the rest of them so on. So right now the instrument is basically going through the cycle, steps of doing cleaning. Basically cleaning will be done through the 60-second purging of the cartridge, and we provide a status for the cartridge on the bottom. Basically we display at the, we are doing a high voltage purge for 60 seconds, and we decrement the seconds. We also display the current, which is very good diagnostic information as far as how the system is performing. Typically for 6 kV separation, a high voltage purge will display around between 12 to 15 microamps of current. And we also display the background counts, the raw counts, which in this case is around 1600 counts. The overall, the PMT for the multiplier tube or the detector saturates at 64,000 counts. So 1600, typically a background noise for a brand new cartridge could be anywhere from 1500 all the way to 6000 counts as a background. So now the next steps are, of course, within the method are dipping. It goes into the water solution, it dips, it goes to the wash, and it cleans the tip. And at this stage it goes to the alignment marker, which was positioned at MA1 position, and it's doing a sample injection, which is around 4 kV, 10 seconds of DNA ladder injection. I'm sorry, not DNA ladder, it's the alignment marker, the 20 and the 1000. And then once that step is done, it goes into the sample, which was positioned at A1, and it will inject again. It's a staggered injection, 4 kV, 10 seconds. And what we are displaying here is background noise in red, and also the current. So once this is accomplished, these steps, and then it will automatically, the instrument will take the buffer tray underneath the cartridge, and the separation will start. This particular separation is 300 seconds. So within 300 seconds, we will see the results. So I'm going to expand the window so you can see it better. So we initially inject some artificial noise, few seconds of artificial noise into the background baseline to make sure the PMT is functioning. And also you can see a kind of a curved picture or curved graph of the current, which is displayed, and we also on the status bar we display the current, which for this particular method it starts off around 25 microamp, and typically this curvature of it will stabilize, and it will be a straight line at somewhere around 18 to 20 microamps of current. And once the electrophotogram shows up, then we will completely remove the current. So you can see now we got some baseline noise, and we are doing the separation. So we just passed the 1 minute mark, and for this particular method, running the PBR322, the first peak, which is the 20 base pair, should come out somewhere around 2 minutes at this region. Of course, before the 2 minutes of the 20 base pair marker, we will have some other peaks, additional peaks, which is the primer dimer. Those peaks, and this tall peak is basically the 20 base pair. So now it follows with the rest of the peaks, which are the PBR 322. And hopefully this separation will be done in less than 300 seconds. We also, in the user interface, we have this slider in here, which we can basically shorten by dragging the slider and hitting the button. We can either stop the run or we can extend the run, depending on number of peaks that come out. If we don't want to wait the 300 seconds or we want to extend the time, we can also extend on the positive or negative direction. So let's go back to the electrophoregram. Anyway, these are the DNA fragments which you will see after the run. We will do the calculation to do the accurate size calling of each peak. This particular region is actually the 4 base pair resolution, which I will expand the table once the complete electrophoregram is done. So we are almost 2/3 finished, and we still have around 90 seconds left. So most probably once the last peak comes out, which is the 1000 base pair, I will stop the method, not completing the whole run. So we're almost there at close to 4 minutes. And now we should have, this is the 1000 base pair, and you can see it finished at 4 minutes. So I'll let it go a little bit more, and then we still have around 50 seconds left. So to really stop the method, what I will do is basically move the slider toward the negative and say OK. And that would basically finish the run. And as you can see, the complete electrophoregram is shown, and also the gel view. And the software automatically identified the lower and upper marker, the 20 and the 1000, and it puts a green arrow on top of it. To do the size calling, we basically go here under the tools and we say calculate. Now we have already we have to load the table for this specific run. We have to load it for the cartridge S1. So we will select the S1. At 20K and 1K with 6K separation. I will select that, open, and I will check mark the save after the calibration, after the calculation, and then I hit the OK, and it will automatically calculate the number of or calculate the base for each peak. And you can see it already calculated sizes. 621 here, upper marker of 1000, lower marker of 20, and then you can see this is the actual 4 base pair separation. Here it says 230, 234. So this is it. Now after doing the ladder run, you're ready to put your PCR product and follow the same steps. Thank you.